In this lesson, we will apply basic trigonometric identities to solve problems in trigonometry. Let's get started with question number 1, where we are required to find the value of sine 15 degree, even though 15 degree is not a well-known angle and it doesn't appear on the unit circle. But we can find the value of sine 15. Sine 15 degree can be written as sine of difference of two well-known angles, 60 degree and 45 degree, because their difference is equal to 15 degree. So now we will apply the trigonometric identity regarding sine alpha minus beta we just learned in the previous lesson. This is sine 60 degree cos 45 degree minus cos 60 degree into sine 45 degree. And if we substitute value of sine 60, which is under root 3 over 2, under root 3 by 2, time cos 45 degree is 1 over under root 2 minus cos 60 degree is 1 over 2 into sine 45 degree is 1 over under root 2. So if we take LCM for both of these fractions, that will be equal to 2 into under root 2. For the first fraction we have under root 3 in the numerator, and for the second fraction we have 1. So this is value of sine 15 degree. Similarly, if we want to find value for cos of 105 degree, cos of 105 degrees, this you can see is equal to sum of the two values 60 and 45. So cos 105 can be written as 60 plus 45. And again, now we can apply formula cos of alpha plus beta. That will give us cos 60 degree cos 45 degree minus sine 60 degree into sine 45 degree. And cos 45 degree is equal to 1 over 2 time cos 45 degree is 1 over under root 2 minus sine 60 is under root 3 by 2 into sine 45 is 1 over under root 2. Just the same way we did before, we take LCM, and which is 2 into under root 2, and this will be 1 minus under root 3. So we can find value of such values for the angle which are not well known, but they could be written as sum or difference of the well known values on the unit circle. So let's go to the next question, which is express 12 sine theta plus 5 cos theta in the form of r sine theta plus 5. So the given expression, question number 3, given expression is 12 sine theta plus 5 cos theta plus 5 cos theta, and we want to write it in the form of r sine theta plus 5. So to write it in the form, which is r sine theta plus 5. So let's take a look what this form is, r sine theta plus 5. If we apply sine alpha plus beta formula on this, this will be equal to sine of theta cos phi plus cos theta sine phi. And if we multiply r from outside, this will be equal to r cos phi into sine theta plus r sine phi into cos theta. Now if you compare 1 and 2, so comparison gives us comparing. Here we have r cos phi and there we have 12. This means r cos phi is equal to 12 and r sine phi is equal to 5. So that is r sine phi is equal to 5. R sine phi is equal to 5. So let's call this as number 3 and this as number 4. We have introduced two unknowns, r and phi, and we need to find these values. From 3 and 4 are by scaring and adding. By scaring and adding 3 and 4. This way phi will get eliminated and we will get the value for r. This will be r square cos square phi plus r square sine square phi equal to 12 square plus 5 square. If we take r square common, that would be cos square phi plus sine square phi equal to 144 plus 25, and r square times 1 is equal to 169. Since r can never be negative, since r is not cannot be negative, so r is equal to 13 by taking square root on both sides. And if we divide 4 by 5 to get value of phi, to get value of phi, divide 4 by 3. So if we do that, then this would be r sine phi divided by r cos phi. R sine phi divided by r cos phi equal to 5 over 12. R will get cancelled and we will have tan phi equal to 5 over 12. This means phi is equal to tan inverse 5 over 12. And here I would like to mention something which is not part of this question, but it might be very helpful for your understanding of calculating the angles. In 4 quadrants, the first quadrant we have x, y both positive. In second quadrant, x is negative, y is positive, and both negative, and x positive and y negative. This is how we determine first quadrant, second quadrant, third quadrant, and fourth quadrant. Always remember that for tan inverse of x over y, this is acute angle, is acute angle, and you can sure use this angle as such. But if x is negative, like tan inverse x is negative, y is positive, it means the angle is in second quadrant, and in that case you can write it as pi minus tan inverse x over y, because this is telling us that this angle belongs to the second quadrant, and for second quadrant we always should subtract angle from pi. And if x and y are both negative, tan inverse of negative x, negative y. Here x and y are both negative, it means the angle is in third quadrant, and in third quadrant you can get that angle by adding pi. So this will be tan inverse x over y. And if you have tan inverse x is positive but y is negative, it means the quadrant is fourth quadrant, and you can simply take the negative sign out and write tan inverse x over y. These are very helpful results, and you will need them while solving questions in trigonometry. Anyway, let's go to the next question. And in next question, what we need to prove is tan alpha plus tan beta. So let's get started with question number 4. Given that alpha, beta, gamma are angles of the same triangle, if so, then sum of the angles is equal to 180 degree. Then alpha plus beta plus gamma is equal to 180 degree. If that is the case, this means alpha plus beta is equal to 180 minus gamma, and if we take tan on both sides, this means tan alpha plus beta is equal to tan of 180 minus gamma. And now you can apply basic trigonometric identity of tan alpha plus beta on left side. So this will be equal to tan of alpha plus tan beta divided by 1 minus tan alpha into tan beta equal to, because this angle 180 minus gamma is in the second quadrant, therefore this must be minus tan gamma. Negative because in second quadrant the value of tan is negative, and because it's 180, the tan stays tan, it doesn't change its ratio. We have explained that in the previous lessons, and now we can cross multiply and we get tan alpha plus tan beta equal to minus tan gamma into 1 minus tan alpha into tan beta. And here we can write this as tan alpha plus tan beta equal to minus tan gamma plus tan alpha into tan beta into tan gamma. And if we bring minus tan gamma from right side to left side, we have tan alpha plus tan beta plus tan gamma equal to tan alpha into tan beta into tan gamma. And this is exactly what we wanted to prove. For the second result, so this was number 4 and now number 5. Number 5. This time we are going to take alpha plus beta plus gamma, but in the question, because it's half of the angles are involved, from alpha plus beta plus gamma equal to 180 degree, because this is second part of the same question. This means alpha plus beta is equal to 180 minus gamma. Dividing 2 on both sides will give us alpha by 2 plus beta by 2 equal to 90 minus gamma by 2. Taking tangent on both sides, taking tangent on both sides, what we have is tan of alpha by 2 plus beta by 2 equal to tangent of 90 minus gamma by 2, and we can apply tan alpha plus beta on the left side, which gives us tan alpha by 2 plus tan beta by 2 divided by 1 minus tan alpha by 2 into tan beta by 2 equal to, because it's 90 minus gamma by 2, any odd multiple of pi by 2 will change the trigonometric ratio to its counterpart. That's why this will be written as cotangent of gamma by 2. And cotangent is in fact 1 over tan, so let's write that down. Tan alpha by 2 plus tan beta by 2 into this is equal to 1 over tan gamma by 2 times 1 minus tan alpha by 2 into tan beta by 2. So if we cross multiply this, this will become tan alpha by 2 into tan gamma by 2 plus tan beta by 2 into tan gamma by 2 equal to 1 minus tan alpha by 2 into tan beta by 2. So by bringing tan alpha by 2, tan beta by 2 to a left side will give us tan alpha by 2 times tan beta by 2 plus tan beta by 2 into tan gamma by 2 plus tan gamma by 2 into tan alpha by 2 equal to 1, and this is what we were required to prove. Trigonometric identities are easy to solve. They just flow like the flow of water. I'll see you in the next lesson.